Hello everyone, this is Monica Rajkumar from Geomatics department and this is my terrestrial laser scanning project for spring 2021. My project it's actually the visualization of FAU upgrades over time, especially from 2007 to 2017. As time passes by, various advancements emerges out in the world. It would be really great if one can visualize the upgrades of a particular area over time very effectively and accurately. Currently, there are very few applications that allows users to visualize the changes between two different years, especially via LiDAR point cloud data. It will be very much easier to figure out the updates that have been made over years when visualizing those on a live web mapping application. So yeah, my project area it's the Florida Atlantic University campus. The primary objective of this project is to develop a web-based application that lets a user to visualize and interact with this aerial point cloud data efficiently so that they can see the FAU campus at two different years, which is 2007 and 2017, side by side and browse through it. The upgrades that have been carried out in FAU from 2007 to 2017 can be seen precisely by point cloud data after creating like intensity maps, elevation maps, and also colorized point cloud data based on the height available. Apart from this, the web application will also allows the user to find the visual differences between the features of those 2 years and directly go to the predefined spots within the FAU campus so that they can spot out the difference in a better way. Also, it lets users to measure the line distances and the area calculation in 3 dimensions accurately. So let's go into the project. The data sources, it's collected from National Oceanic and Atmospheric Administration, which is NOAA, and the United States Geological Survey, which is USGS. The 2007 LiDAR data was collected from USGS. Actually, it was covering a larger area for the whole Boca Raton. Also, 2017 LiDAR data was collected from NOAA. It was collected for the whole Palm Beach County. And the aerial imagery, it was collected from USGS. For each year there were 2 tiles available so that in future we can just crop it to the FAU region. So before getting into the project, we need to process the data. First, all the point cloud data that I collected was in the format LAZ. I just converted it to LAS files for both 2007 and 2017 and then cropped those LAS files and the aerial imagery for FAU region so that it will be very much easier to just get into our project area. And then I have created a last dataset from the cropped LAS files. So after our pre-processing is done, we have major components which is to be created from this point cloud. So those are digital elevation model, colorizing the LAS files, and the creation of intensity maps. So these 3 components has to be created from the data and then it has to be published as scene layers in the ArcGIS online so that it can be easily used in the web application. So yeah, these are the 3 major components. Once this is published as scene layer, we can use this scene layer to create a scene map for both 2007 and 2017 separately. So now as we have 2 scene maps separately, these 2 scene maps can be put together and a web application can be created along with the addition of certain tools which we can add up to the application. So I have published all the 2007 scene layers, scene map in the respective folders 2007 and 2017. So let's fly through the web application, what the application actually is. So the one which you see is the web application for the visualization of FAU upgrades over time. So the left side, we can see the 2007 data and the 2017 data is seen on the right side. So there is an information tool available for the user where they can see what the application actually is. There is a layer list tool here in the left corner in which you can see what all the layers available for 2007 and 17 respectively. So we have added the colorized 2007 FAU data and the point cloud data, which is colored by elevation, and then the aerial data and intensity as well as DEM. This is available for both 2007 as well as 2017. The eye icon which you see here is used for the visibility. So if you toggle off, then the layer will be not present in the map, and you can just toggle it on again so to see the layer. So yeah, now we have a tool in the right corner of the web application which has predefined spots so that we can go to the FAU campus areas where there are the changes availability present. So yeah, if you see here, this is the tennis court of the Florida Atlantic University. In the right side, which is the 2017 data, you can see the tennis court, but whereas in the left side it's not present. So which means in 2007 there was no tennis court available. So we can visually see the difference of the campus. So the left side that we see now is the point cloud data, which is colored by elevation, and the right side is the intensity map. As you see here in the Henderson School, we have a building here in 2017, whereas here it's not there. So this is the intensity and the point cloud colorized map of both years 2007 and 17, which we can visually see the stadium. It's not present in 2007, whereas it's there in 2017. So there is also a legend tool available based on which we can see the elevation data, which color represents what. And the right side which we see is the aerial imagery. We can see the band availability of that particular aerial imagery. So the same differences can be also visualized using DEM. So the one which we see now is the digital elevation model of FAU in 2007 and 17. With respect to stadium, if you see, there is no stadium in 2007 since it was built only in 2011. So yeah, the same thing can be visualized in intensity more clearly than DEM. And this is the Parliament Hall, which is not there in 2007, but it's present in 2017. This Parliament Hall is also added as a predefined spot from the tool, which you can directly go to the spot and see what the difference is. So apart from this, we have also added a measurement tool using which you can calculate the area in 3 dimension. So if you find any changes, if you find like a building has been established or constructed over years, you can just find out what exactly the area that has been used. So if you see the region near Indiana River Street, there is a car parking availability in 2017, but that is not available in 2007. So we can find out what area has been occupied and how much area we can more occupy for the car parking in future. So this type of assumption can be seen from this web application. Also, we can measure the distance of any line feature. So this is actually the Innovation Village North, which was constructed only after 2007. So it's not present here in 2007. It's only there in 2017. So you can measure the distance of the construction, maybe the wall or even the road, whatever distance that we want, we can just calculate from this tool available. Not only in metrics, all the units are available, so we can just choose what units we need and directly we can go measure it. And yeah, the whole web application has been hosted in the GitHub, which is open source. So let's short demo of the application in GitHub. So this is the application which you can able to browse through, and yeah, you can just view it in 3D. You can just move it, and if you want to go back to the original FAU extent, you can just click home so that we get the original extent. And here's the layer list with which we can just view the colorized elevation, or you can say you need intensity or you need DEM. You can just handle that. So if you see colorized and DEM, you can also see the legend what it is. So here it is. So not only in 2007, the same thing can be done in 2017 also. There is the same layers present in 2007 and 17, and we can just see the differences. So now let's move on to the predefined spots. So this is the point cloud color by elevation difference, and we have the stadium here. Maybe we can just see it in the colorized, not in the point by elevation, so that it will be better. So then here is the tennis court, which we can see in 2017 and not in 2007. The Parliament Hall, then even the FAU club, it's there in 2017. See, you can see it here. This is the club, but it's not in 2007. And the Innovation Village North, which is here but not here. These two maps are all already synced, so whenever you zoom in or zoom out, the both map gets the same extent, so it will be better for the visualization process. So you can go to the Henderson building, which you see here. There is a building, but here it's not there. And you can do the same with respect to DEM. You can just see the difference in the DEM. So yeah, apart from this, we can now use the measurement tool. How it works. See the stadium. Let's just see this. So here is the measurement tool. If you see, it's actually asking me which point I should click. You see the light orange line. So I should just choose a point for which I need to calculate the area, and then can just go and click it. So a 3D surface will be generated, and you can see the area. You can see in all metric units, square kilometers, so everything you can do. So if we want to measure the distance, then you can measure the distance from here. So we can also choose the units here. So yeah, this is the application is all about. So the references which I have taken is the LiDAR Explorer, from which we collected the data, the Nova, USGS, and the ArcGIS platform, which allowed us to publish scene layers and create a web application out of it, and the JavaScript API, which I used for the coding purpose to build the web application, and the GitHub in which I hosted the web application. So the future scope of this project is, I have just used the 2007 and 17 data, but we can add more years so that we can track the progress of a particular region over years. Also, we can just overlay the temporal data in map and then swipe and see the differences without having two maps side by side. If that's going to be like 10 years, then it's really difficult to create 10 view of the application. So instead of that, we can add all the temporal data in one map, overlay those, and then just choose which layer we want to visualize and just swipe and see the updates. And we can add a query tool in the web application, and we can also classify the point cloud data and then add it to the application, so that we can query just the tree features or query just the building features, so that it makes more appealing. Yeah, thank you for the wonderful opportunity